part 2. This is the second half of the review. Make sure you watch the video for part 1 and understand everything on there. Pencils down, of course. Do not have a pencil in your hand while you watch me work. Go back and do it yourself. Stop cheating. All right, problem number 1. So, to solve this equation for x, we definitely want to divide both sides by 8 as the first step. Just get that 8 out of there. Kabam! So that's going to give us log base 6 of 4x minus 25 is equal to 3. Now, we need to rewrite this in exponent form, starting with the base. This will be 6. These will trade sides, so this will be 6 to the 3rd power equals 4x minus 25. Notice, no more log. Some kids are dropping that down. This is exponent form now. 6 to the 3rd power is 216. All right, so this is 216 is equal to 4x minus 25. So we will add 25 to both sides. So that's 241 is equal to 4x. Then we will divide both sides by 4. Oh yeah. So that is going to give us x equals 60.25. All right, number 2. This one, when you are adding logs, you can condense them by doing multiplication, all right? We're using the rule that said log A plus log B is equal to log AB. So we're condensing. So in this case, that means log base 6. This is my A and that's my B. So it's like having x minus 5 times x. And that's equal to 2. Okay. Yeah, we have to do the distributive property. So this is log base 6 of x squared minus 5x is equal to 2. Now, when the log is only on one side, and we don't have like bases, we need to rewrite this in exponent form. So in exponent form, starting with the base of 6, bring that down. No more log because it's exponent form. Now these two parts will trade sides. So the 2 will come over here and become a power. And this part will go over here. 6 squared is 36. Okay. In order to solve this, we need 0 on one side, so let's subtract 36 from both sides. Okay, so that gives me 0 is equal to x squared minus 5x minus 36. All right, we need to factor this or use the quadratic formula. X squared can only be x times x. Now 36 can be several things. The first thing I think of is 6 times 6 is 36. But it also could be 4 times 9. All right, it could also be 3 times 12, or even 1, whoops, I almost left out one. It could be 2 times 18, or it could be 1 times 36. Could be all of these things. Now, the inner plus the outer has to give me the middle, so keeping an eye on the 5, I'm especially liking this one. So let's try that out. 4 times 9. Now inner, I've got 4x. Outer, I've got 9x. That has to make the middle of negative 5. So if I have a positive 4 and a negative 9, that would do it. Okay, so there's my positive 4 and there's my negative 9. Of course, we have to keep going and find out what x is by setting each of these factors equal to 0. Alright, subtract the 4, you get x equals negative 4. Add 9. Okay, so gotta keep this separate. Add 9, and that's going to give me x equals 9. Alright, but we have to check and make sure that none of these solutions are extraneous. In fact, I should have checked that over here as well. Yeah, this looks good. I'm making sure that if I plug in the value, I don't get a negative number. 4 times 60 is huge. Alright, minus 25, that'll be positive. Okay, can't have any negatives. Okay, if I put negative 4 in for x, well, right there, that would be the log of a negative number. So that's a no-go. Also, if I put it in here, negative 4 minus 5, that's negative 9. So I'm getting negative numbers when I plug this in. So that means this is not an actual solution because it is extraneous. So cross it out and write the word extraneous next to it. 9 on the other hand. If I put in 9, that's 4. And if I put in 9 there, obviously that's positive. So that's going to be fine. So x equals 9 is the only solution. Okay. Let's see, that was number 2. So let's find number 3. Alright, this one we have the log on both sides. So we can just drop those logs out and realize that 4x minus 1 should equal 2x plus 5. Let's subtract 2x from both sides to get those x's in one place. 4x minus 2x is 2x. Then we'd want to add 1 to both sides. So that'll give me 2x equals 6. Time to divide. So x is equal to 3. If I plug that in here, I get a positive. 4 times 3 is 12, minus 1 is 11. It's all good. It's all good. Okay, number 4. We're back to condensing again. When we added before, it condensed as a multiplication problem. All right, addition became multiplication. Subtraction, though. Subtraction becomes division. Remember, log A minus log B can be written as a single log A over B. That's the rule I'm about to use. So if I condense these, I'm going to have to do this divided by that. So x squared plus 15 over 3. And all that is still equal to 5. Alright, that's as far as I can go here. It is time to rewrite this in exponent form. So start with the base, which is 2. Bring that down. 2. Now these two parts are going to trade sides. So the 5 is going to come over here and become a power. This whole fraction is going to come over here. Alright, now 2 to the 5th power turns out to be 32. Alright, still continuing to try to solve for x. Let us multiply by the denominator. Alright, so that's going to be 96. So 96 is equal to x squared plus 15. Now, we just only have the one variable, x squared, so we can continue to get this by itself. Just subtract 15 from both sides. Okay, so that's going to give us 81 is equal to x squared. How do we unsquare things? Yeah, we use that square root of both sides. Whenever you take the square root of both sides, though, the solution will be positive or negative. Okay, so that's plus or minus 9. So please understand that that means either x is equal to 9 or x is equal to negative 9. Either one of these would be true. All right, that was number 4. Let's find number 5. Which of the following is equivalent to this? All right, so you see how these are all expanded? So basically we're expanding this, and we'll look and see what it is. So expanding. Remember, remember that multiplication expands out as addition, and division becomes subtraction. But the bottom line is anything in the numerator is going to give us a positive term. So see that 16? I'm going to have log base 4 of 16. Make it positive. See the y to the 4th power? This is going to be another positive term because it's in the top. So I'm going to put plus log base 4 of y to the 4th power. Now anything in the bottom is going to give us a negative term. So negative log the square root of x. So we have this. Now remember with the exponents, first of all, the square root of x is the same thing as the 1/2 power. So let's make that change. So I'm changing that square root of x to the 1/2 power. It means the same thing. Now in expanded form, these powers go in front of their term. So my final answer would be, well, okay, let me come back to that first term. This 4 is going to go in the front. So I'm going to have 4 log base 4 of y minus, and then I'll have 1/2 log base 4 of x. All right, now I pause on this one because this we can evaluate. 4 to the what power is 16? It's 4 squared. So that's what we're looking for. Let's see, what do you got for me today? It's A. A is the same thing. All right, so that's why the answer to number 5 is A. Okay, now going in the other direction, condensing. Any coefficient like this is going to end up as the exponent. So this would be like log base 2 of 9 minus log base 2 of x to the 9th power. Now, remember that subtraction condenses down to division. So this would be log base 2 of 9 over x to the 9th power. That's it. Okay, and that seems to be right there. So that's why the answer to number 6 is E. All right, number 7. Okay, which of the following is not correct? Well, let's just check them one at a time. Addition condenses down to multiplication. So this should be log base 2 of, and then 3 times 12 is 36. Okay, but they have log base 2 of 15. Oh, no, no, no. You don't just add 3 plus 12. You're supposed to multiply. Okay? You know, sort of like we did down here with the 36. See, this is correct. This is how you do it. 4 times 9. And when you subtract, you divide. Like 18 divided by 9 is 2. So we didn't subtract, we don't add, we multiply. So A was wrong. So that's the one that's not correct. Okay. let's see, is number 8 on this paper? No. Flipping over to the back. Condensing. Easy peasy. This 4 is going to come over and become the power. So this will be log x to the 4th power plus log to the 5th power. So when you condense, addition becomes multiplication. So this will be log of x to the 4th power times 5, but we would traditionally write that 5x to the 4th power. Okay, that's it for number 8. Number 9, expanding. All right, anything in the numerator is going to be a positive term. So natural log of n to the 5th power. Oh, that's supposed to be 5th power, not 5n. Okay, natural log n to the 5th power. Make it positive because it's in the numerator. Now, how about the p? Natural log of p to the 6th power. I'm making it positive because it's in the numerator. Now, this term is in the denominator, so I will make it a negative term. So negative natural log r to the 7th power. Now, in expanded form, each of these exponents need to wind up in the front of their term. So I will have 5 natural log n plus 6 natural log p minus 7 natural log r. And this would be expanded form. Okay, number 10, finding the inverse. Please remember that this is basically like a y. To find the inverse, we switch the x and the y, and then we solve for y. So if I do that, the x will be here, and the y will be here. So I've switched the x and the y. Now I have to solve for y. Well, this y is inside of this log function, so I'm going to have to switch to exponent form. So please remember that natural log is an invisible base e. So when I get ready to switch forms, I need to start with the base always, but my base is that e. Okay. Meanwhile, the 7y and the x part change sides. So the 7y comes over here, and the x comes over here, but it becomes an exponent. All right, this is exponent form. We're trying to solve for y, though, so you would then divide by 7. Okay, so that's going to give us y equals e to the x power over 7. So that is the answer, but go ahead and put the f back in here, but we will call it f inverse by putting a little -1 on it. That's read f inverse. Act like you know. So yeah, so that's number 10. Groovy. Now number 11, same thing. This is like a y. So we have to switch x and y and then solve for y. So if we switch x and y, then we get x equals 2 times 3 to the y power minus 1. So I have to get this y by itself. But first, I have to get this base and power part by itself. So which do you think I'm going to do first? Divide by 2 or add 1? Yeah, I'm definitely going to add 1 first and divide by 2 later. Okay, so if you said something else, change your brain. So I have x plus 1 is equal to 2 times 3 to the y power. Okay, fine and dandy. Then I will divide by 2. Okay, so I get all this goodness. So now I've got this. I've got x plus 1 over 2 is equal to 3 to the y power. All right, that's as far as I can go with algebra skills. like algebra 1. So now to get this variable out of the exponent, I need to use log form. Start with the base. The base is 3, so I do log base 3. And these two things are going to switch sides. So the y is going to come out front, just like we wanted. And then we will have our x plus 1 over 2. This is the answer, guys. I mean, I'm serious right now. Let me make sure there's nothing over here. But I will go ahead and write my answer using an F. Oh, I'm sorry, G. It's almost a travesty. G, but we'll make it G inverse by putting a minus 1 on it. So G inverse equals log base 3 of x plus 1 over 2. What? Bam. That's number 11, y'all. Absorb it. Number 12. This is like a y. So we switch x and y, and then we solve for y. So if I switch x and y, I will have x equals natural log y minus 4 plus 3. Now I need to get y by itself. No, I'll start with blue. Let's get rid of this 3. So subtract 3 from both sides. That gives us x minus 3 equals natural log of y minus 4. Okay, that's as far as we can go with algebra 1. Now we need to rewrite this in a different form. It's in log form, so let's try exponent form. Please understand that natural log is an invisible base e. So when I rewrite this in exponent form, I'm going to start with that e. Okay, now the x minus 3 and the y minus 4 are going to trade sides. So I will have y minus 4 out here, and I will have x minus 3, alright, will become the exponent of exponent form. To get y by itself, you got to take one more step, adding 4 to both sides. So you get what you get. E to the x minus 3 plus 4. So that's the answer, but let's put back in our h. But of course we will call it h inverse by putting a minus 1 in there. Okay, so that is the final answer for number 12. How about number 13? Okay. So that's y. So switch x and y and then solve for y. So switching x and y, you get x equals log base 7 of y plus 6. Now this is already by itself without anything multiplying or adding on the end, so it's already time to switch to exponent form. Starting with the base of 7. So we will bring down that base of 7. So the x and the y plus 6 have to trade sides. Okay, so the x is going to come over here and become the power, and the y plus 6 is going to come out here. And then we just subtract 6 from both sides. So that's going to give us y equals 7 to the x power minus 6. And put the f back in there. Alright, we'll give it a negative 1 to make it the inverse. F inverse equals 7 to the x power minus 6. Alright, that was number 13. Alright. Okay. Inequalities, and we're given the graph. This is going to be a piece of cake. Easy. That means it's going to be easy. This says the function is less than 4. Less than. Is this above or below? Less than means below in this context. So I want to know which x values have the function below 4. So, well, look at the function, the blue here. And of course, the red line is the 4. So the function is the blue line. So which part of this is below 4? Well, clearly it's this part right here. Okay? So please understand that this part where it's right on the line, this is like the cutoff point. All right, that critical value. So the question is, as I look at it more as a number line, are the solutions going to be on the left of this point or the right? Well, looking at what we just highlighted, this is going to the right of the point. So these are the x values that we need. Okay, the ones that are going to the right, just like we said. So, as far as a number line goes, let's make our number line, guys. All right, so our critical value is right there, but it's the x value that we really need. That is negative 1/2 is the x value. This is less than, not equal to, so let's rock the open circle. And we decided that we needed the solutions that go to the right. The x values go to the right, because to the right is where we are below 4. So we will go to the right. So this would be our number line graph. And interval notation then would be negative 1/2 to infinity. Check it out. And I use a rounded parenthesis because same reason I did an open circle. All right, we want to be less than, not equal to. So negative 1/2 itself is not to be included. And a round parenthesis means don't include this value in the solution. So that was number 14. Told you it was easy. Trust me. Okay. Once again, this is our critical value right here where they intersect. This says the function has to be less than or equal to 2. So is that above or below? Okay, well, once again, that is below. So is it this part or this part? All right, obviously below is this part. Okay, now what we need are the x values, like a number line. So do I want the part on the left or the part on the right? Yeah, of course I want the part on the left, all right, because that's where the below part of the graph was. That's what we just showed. Now be careful though. It looked like I was going to negative infinity just then, didn't I? So I should correct that so it doesn't look that way. The reason why I'm being so cautious is because logarithms have an asymptote. See how the graph is bending right here, swerving? This is a vertical asymptote. So we're not going to go past this. In fact, we never even reach it. So this is 0. Okay? Can't get there. So, if I were drawing the number line values, I would go bam, and I'd have to stop right there. I shouldn't make an arrow. So when I go to make my number line, to reflect what I've learned here, start with the critical value. Now we're doing a number line, so this is strictly x values, okay? So all I care about right now is the 9. So there's my critical value. Let's see, is this an open circle or a closed circle? Yeah, it's going to be a closed circle. It is, or equal to, so we'll include the 9. And did we say we were going to go left or right? Yeah, we said we would go to the left because that's where it's below, all right? Less than is below. So I need to go left, but I need to be careful when it's a logarithm and I'm going left. It's got to stop at 0, people. So I'm going to put up a roadblock right here, open circle. Okay, so kabam. This is what the number line graph would look like. All right, why did I leave that in open circle? Remember, this 0 is the asymptote. You never reach it. You never get there. So you can't include 0 as part of your solution set. Now, interval notation. Clearly, the solutions are from 0 to 9. Not including 0, but including 9. So we'll go 0 to 9 with a round parenthesis and a square bracket. And there you go. So that's number 15. Oh, whoa, was that the end? Whoa, that's a gift. I thought there might be more. All right, guys, that was the end of this assignment, end of this lesson, if you will. I hope you weren't copying off me. I hope you did. Did I remember to say put your pencils down? Well, I guess it's too late now. I will see you on the next video. Make sure you watch part 1 and know everything on there.